started. Welcome everybody. Today we're going to introduce to you the Charles Law. My name is Adrian Esparza.
I'm Dr. Clement, following with Jerry Delfino and my guy Samir Gill.
Technical difficulties. So, Charles Law was named after a scientist, Jacques Charles, who formulated the original law in its unpublished work from the 1780s.
This law describes how gas expands as the temperature increases. Conversely, a decrease in temperature would be a decrease in volume. For comparing the same substance under two different sets of conditions, the law can be written
as you can see here, volume 1 over temperature 1 over volume 2 over T2. I just gave away the next part of our segment. V in this equation stands for volume. T in this equation stands for, you guessed it, temperature. Volume is measured in liters and temperature in Kelvin.
As you can see, we've written out a problem for you.
A prime example.
The problem states that there are 13.45 liters of gas in a container at a temperature of 1,600 Celsius. If the gas was cooled until the volume decreased to 9.5 liters, what would the temperature of the gas be? So, we start by labeling our variables. So this would be, as you see, liters would be volume 1. This would be the temperature 1. And since we already have one volume, this right here will be volume 2. And as you can see, the temperature is not given, so it will be our variable which we will be solving for. This is just an organized way to sort out your equations. As you can see, you can't have this in Celsius, you have to convert it into Kelvin. So you have to add 273 to the original Celsius degrees. That'll be X equals 1,873 Kelvin. So now, only thing you have to do is plug all these variables into this equation. So you write volume 1 on top, which is your numerator. You write temperature 1, which is 1,873 Kelvin, as your denominator. Then you write 9.5 as your numerator on the opposite side, and X, which we will be solving for. So one way you can solve is going cross, but easier to do cross multiply, which we will be doing. So first, on the right side, put 13.4x equals 17,793.5. And you basically just solve, which you would divide 13.45x, which will cancel out each other. And your answer for this equation will be 1,322.93. And since this is in temperature, it will be in Kelvin. And that, to you, my people, is how we solve it the Ms.Parra way.
From everybody here at the set, we just want to say thank you all for joining us. Ms.Parra, give us a good grade, please.
I love you, Ms.Parra. And shout out to my guy, Samir Gill. Without him, we are nothing. And without him,
Dude, that
our,
fucking-